Ascierto. I'm Research Director of Data Center Technologies at 451 Research. And while we cover many areas of data center facilities, technologies, power, space, cooling, design, prefabricated modular data centers, and so on, one of our focus areas is indeed data center management software.
There we go.
And I wanted to show, I'm responsible for this chart. You may have seen it. There are some 70-odd suppliers of DCIM out there. And while they all advertise many features, I created this chart to sort of help people understand a little more clearly and at a very high level that indeed there are some offer certain features, but not all of them. So with that, I'd like to hand it over to Bill Dougherty. Thank you.
Great. Thanks, Rhonda. So our plan today is to do a little bit of a Q&A as to our experience trying to implement DCIM. And before we do that, I've got a few slides to go through talking about the journey we've been on. And I say journey because we're not yet done, but it's useful to know where we were and what it is we were trying to accomplish. So our legacy, we had 15 years in this space trying to manage our buildings. We're a multi-tenant co-location with facilities in California and Ashburn, Virginia. And what we had was 15 years worth of legacy systems. All of these were silos. So we had a system for monitoring branch circuits and a different system for temperature and a different system for batteries. And they were really good at what they do for monitoring and controlling, but there was no interoperability. And there was no transparency, no ability to share this data with my customers. My customers would really like the data. So we took an approach that said we wanted a system that would let us break down these silos. And the basic concept was we needed something that could collect data from everything. So we needed a platform that could suck the data out of whatever the tool it was. It would talk many different protocols and allow us to then normalize that data. As an example, we have multiple branch circuit monitoring solutions. They don't report data in the same way, but when I bring it in, I need to normalize it so it looks the same. And then we want to be able to visualize that data in a variety of ways. We want to visualize it through alarm dashboards and graphs and 3D floor plans, et cetera. And we really had 4 goals that we were trying to accomplish. The first was unified visibility. I wanted one screen that I could look at where I could see all of my buildings wherever they were and could then drill down into the details, whether it was the power, the mechanical systems, the temperature, et cetera. And I wanted operational transparency, which meant that in those silos, the people using those systems had really good information about how the building was running in their sphere, but we couldn't see it within the rest of the organization. And we also couldn't share it with our customers. So we wanted operational transparency. And then from there, we also wanted operational efficiency. And really for that, we're focused on lower in PUE, yes. But our PUE is pretty good. We're really looking at things like unified alarm consoles. My operations staff is getting alarms from all of these different systems. We want to bring that together, do event consolidation and normalization of events. Also, we have a lot of manual effort that goes into running our building, and we wanted to streamline that and get rid of the manual effort. And then lastly, we wanted a system that helped us manage capacity. Capacity for us is inventory, it's money. It dictates what I can sell and when I have to build the next building. So those are our 4 areas we were looking at. So let's talk about what we've learned. And really, I've talked a lot at these conferences about the good side of DCIM, so today I'm really talking about kind of the bad things. First thing we learned is we don't know what we don't know. And that becomes a problem when we're trying to plan and implement one of these systems and do it on time and on budget. What I mean by that is we had pieces of software running in the building that were installed 15 years ago by somebody who no longer works for us. It's not well documented. It uses a protocol that we've never seen before. It makes it very hard from a project perspective to figure out how I'm going to take data out of that and normalize it. Also, we had things that weren't working well in the building, and the operations team that dealt with it knew about it, but there was no operational transparency. So we had a set of older CRAWs that were no longer really talking to their control software, and so the ops team had a manual effort to go and adjust those CRAWs. We, as the implementation team, the IT team, had no visibility into that, and so we chased our tail for a couple of weeks trying to figure out why we were getting garbage data out of these systems. So I like to say that DCIM can illuminate the dark corners of your data center. That's a good thing. We want to get rid of those dark corners, but it's also a bad thing in terms of trying to implement one of these tools and get to an ROI. Second thing we found is our equipment vendors have poor documentation. They suck. Sorry if any of them are in the room, especially our older vendors. And what I mean by that, I'm going to drill into this because it's a little hard to see. We have systems that talk Modbus or BACnet or ArcNet, and the manufacturers can't tell us what the registers mean, or they give us documentation and what they tell us is wrong. And so what we had to go do was play detective, and this is the process we would go through. We would do a Modbus crawl a device and get data back, and then we had to guess, what did these different registers mean? This is an air handler, and I challenge anybody to look at this screen and figure out what those registers mean. So we'd come up with a theory and say, we think this register means this, and then we would go to the device and try to prove out that theory, and we would iterate our way through this until we had mapped the entire device. That worked okay, except for we had situations where I had two air handlers purchased 6 months apart, look identical, same faceplate. I go map the first one, hit the second one, and the registers are different. It's a problem when you're trying to implement this software on older pieces of equipment. And then once we did all of that, we realized that we have too much data. I have 75,000 objects that I'm monitoring. Each of those objects produces between 10 and 15 points of data, some of them more, which means on every polling cycle I get 1 million points of data, and I really don't need it. This is an example of a UPS. And that UPS has, I think, 30 different points of data, but from the perspective of my operators using this system, they need 3 to 5. And 99% of the time, they don't need the rest of the data. If they're in a situation where they need that very obscure data point, they're not looking at the DCIM system anyway. They're going straight to the device. But from an implementation standpoint, we had to map all these pieces of data. We had to validate them. We now have to store them every 5 minutes. We have to graph them and report on them. It adds a lot of cost, but we were faced with this challenge. Do we optimize as we go, or do we just collect everything? And the mistake we made is we started off saying, let's collect everything. Now we're going back and optimizing that. And visualization, something we said we wanted to do, is hard. This is what we started with. This is a CAD drawing of one of my buildings. This is what we wanted to get to, is the nice, pretty 3D interface that all the DCIM vendors like to display. This is really difficult to do. The first time we did it, we realized that our CAD drawings were wrong, that in some cases they were a couple feet off, which didn't make any difference in terms of how we ran the data center on a daily basis, but when we tried to map information onto this, and you've got icons that expect a certain size, you map it and now not everything fits. So we had to send guys out with clipboards and tape measure to remeasure the entire data center. And when we went through all this, and maybe somewhere between 40-45% of our effort early on in this project was working on these 3D interfaces, what we discovered is this is the least useful screen in the system because my operators don't need it. My operators want alarm consoles, and they want graphs, and they want dashboards. They're really not looking at the 3D interface. And the same thing is actually true for many of my customers that we've shown them this. This dashboard is the least useful thing for them as well. They want historical trends. They want to know how much capacity they have. They don't need to see the whole building. All this brings us to the conclusion, before Rhonda starts peppering me with questions, that DCIM, while useful, it takes longer and it costs more than you think. From a project perspective, we're about 9 months behind where we expected to be. It's cost us a lot more money in terms of manpower, in terms of effort. It's still a useful thing to go do, but whatever you think you're budgeting in terms of time and money and resources, double it and you may be close to reality. And with that, I'm going to turn it over to Rhonda for questions.
Thanks, Bill. I do have a lot of questions. I am going to open it up to the audience as well, but first off, I just want to start at the beginning. How did you approach the RFP process? I mean, you know, there are so many suppliers out there. What was your methodology?
Yeah, so we started trying to figure out what does DCIM mean to RagingWire rather than what it means to other providers or to other companies. And we wrote about a 20-page RFP.
20.
And we sent it out to everybody in the marketplace that said that they had DCIM, which was a lot of people. Really, there were 13 major vendors that received it and indicated some indication that they were going to respond. I believe we got 9 responses from the major players. And many of those players, I already owned pieces of their software because pieces of their software represented those point solutions. So we then scored them all and evaluated them based on what we were trying to accomplish, which was the data collection, the data normalization, the visualization, and the ability to not only use this for our own internal operations staff, but also eventually turn it over to our customers.
So you told them what you wanted quite specifically in 20 pages.
Yes.
And it worked, it sounds like.
To a degree, yes.
Okay. Did you do a proof of concept trial?
We did an initial proof of concept. We started with one building, and we started with a subset in that building, which was focused on the 3D visualization and the electrical system. The end of that was successful enough that we chose to continue going forward. We did uncover some problems with the tools, but really worked closely with our vendors, product management group, trying to get past those items.
So was it worth, because proof of concepts, that's money, that's time. Did you have to pay for those proof of concepts? And
yeah, the arrangement we had with our vendor was we licensed the product. We certainly paid for the professional services to help us make it work. But we had some out clauses that would get us out if we were unhappy.
So you only trialed one product then?
Yes.
Okay.
Yeah. I didn't have the internal resources or the time to try to make 3 or 4 different vendor solutions all work.
Okay. So I guess the obvious question is, with the benefit of hindsight, what would you have done differently, either around the RFP stage, the proof of concept, or indeed the deployment?
Yeah, we made one critical mistake in this project, and it had to do with the way we implemented it. So we had great involvement and a team put together between the IT staff and the facility staff and the engineering staff during the RFP process up to vendor selection. And then once we selected the vendor, we told the operations staff and the engineering staff, it's going to take us a while to implement this, to just build the servers, install the software, start connecting to these things. And so we allowed them to disengage from the project while we went and did a lot of that base infrastructure work. And by the time they came back and re-engaged, there was a whole new education cycle we had to go through. And so really what we would have done different and what we're trying to do now is to have a cross-department team that's on this every day. So we have operations people dedicated just to implementing DCIM, sitting side by side with my IT staff.
And how many? I mean, you said that you should, it cost you more in resources, internal resources, than you expected. Can you just talk us and help us understand a little more about, what are those people doing?
Yeah,
why is it so hard?
So I have a dedicated project manager.
One person?
One person, and he manages probably 5 or 6 projects, but this project's probably 90% of his time right now. In addition to that, I have 3 dedicated application engineers just focused on this project. I have a couple of other application engineers that spend parts of their time on this or are dealing with other aspects of our stack but trying to do the integration. We now have 1 full-time dedicated facilities operations person on this project, and we're doing kind of a train-the-trainer situation. So he's going through testing out all of the use cases and then is training the other staff. And so we're sucking up quite a bit of time of the rest of the operations staff. And then beyond that, the project has involved bits and pieces of my network engineer's time, my system engineer's time, the electrical engineers, mechanical engineers' time, a lot of consulting around how we're going to tune the system, trying to figure out what are the data points that they actually need, what should the thresholds be, how do we get more useful information out of the system faster.
Do you think this is going to be a fairly long-term sort of resource commitment, or do you expect that as the product becomes more tuned to your requirements, Are you expecting those resources to go down over time?
I think we will see a reduction in those resources a little bit, but I don't see this project ending, which is not atypical for most of our large enterprise projects, whether it's my financial system or my customer portal or name your system. We're always going to be innovating the platform, adding new features, and also we're on a steep growth path. So we just opened a new building in Sacramento last month. We have a new building coming open in Virginia in 6 months. We're going to new geographies. And as we go and we build, there's a new implementation process with these tools. Because every time we build a new building, we also rev what are the electrical systems, the mechanical systems that operate that building. And so every time we hit a new building, there's a new cycle of trying to make it work with this tool. It's just a platform.
Right.
But you now have to bring things into that platform.
Okay, one of the things you said that I suppose surprised me was about the protocols that the equipment itself communicates from. I mean, one thing we often hear is from vendors is that we speak to all the major protocols, but it sounds like that's obviously critical, but there are problems with that. How did you decide sort of what registrar, for Modbus, for example, with your cars, how did you decide and come to the decision of what that registrar should look like?
Brute force.
Okay.
It was 2 or 3 guys sitting there looking at a screen, trying to analyze the data, comparing it to reports or manual things and saying, okay, we think based on experience that this number looks like fan speed, or this number looks like supply temp. And okay, so now we have a theory, and let's pretend that's what it means, and let's chart it and see if, as the day progresses, as the operational state of the device changes, if the numbers move the way we expect. Let's send somebody down with a clipboard and a radio and have him look on the front of the device and say, okay, we think the fan speed is 2,600 RPM, what do you see? And most of the time we were wrong the first 2, 3, 4 times. It was an iterative process. And so yes, they speak a standard protocol, but whether you're talking BACnet or Modbus or SNMP, you name it, you still have to know what the addresses are.
Right.
And we also hit some funky protocols. We have some air handlers that speak ArcNet.
I've never heard of that.
I don't know if anybody in the room has experience with ArcNet. It was a DECVAX protocol I haven't seen since I was in college, and I was in college a long time ago. I didn't have anybody on my staff that even knew ArcNet, so we had to go dive into the manuals just to understand what is this thing that we now have to go talk. Fortunately, the software we chose had the ability, working with the vendor, to go talk that protocol, but we still had a learning curve, and it delayed the project.
That's not really that's not your DCIM vendor's fault, though.
No.
I mean, that's an equipment issue, but I guess you weren't expecting that. I mean,
and I think there's an important point to be made here. None of this is necessarily their fault. I know the title of our presentation is what they didn't tell us. They also didn't know. And regardless of who we chose, we would have run into these situations in our building of we don't know what we don't know. We would have run into the problem that our CAD drawings didn't match reality, which meant that if we're going to use those as our source of truth for 3D visualization, our visualization isn't going to match reality. We would have run into the problem of how do I deal with ArcNet? And so this isn't about a vendor, it's about the whole concept of if you're going to put in an enterprise class DCIM solution, one piece of software to rule them all, understand what you're getting into before you start.
Yeah, I was surprised that your comments about the 3D visualization dashboard, because that's kind of the wow factor. That's the one thing my children are impressed about with what I do, is the 3D visualization, and it's certainly a powerful tool. When it's being demoed. Why wasn't that? I mean, I've heard that 3D visualization is really useful for the technician on the floor. They've got instructions maybe, but they can't actually find the port or things, I've heard that's a really powerful tool for the technician. Was that not the case for you? Or?
It looks really cool. Without a doubt. We've got it up on the monitors in the data center. You come in for a tour, you're going to look at it and go, wow, this is the best run data center ever, because look at this cool screen. And my going in assumption was this was going to be very powerful. That when a branch circuit throws an alarm, for us the alarm comes up and says something like circuit number 1.2.4.7.12.32.6 just crossed just tripped. And where is that? Well, from an operations standpoint, they know where that is because that number I just rattled off means something to the operator. So the 3D visualization kind of shortens the learning curve for some of those guys, but they really weren't paying attention to it. We've walked them through it, and they're saying, yeah, that's nice, but we're not really going to look at it on a daily basis. What we're really going to look at are these other things. And the other problem with it is for us as a colo, we have customers move in and move out every day. So the floor plan changes daily. Yesterday there was open space there, now there's a rack. And so you have to adjust your workflow to have people update that 3D map every single day. And so the usefulness compared to the expense of trying to do it, really, really, really low return on investment there, probably a negative ROI on that feature. Now from our vendor, they have other very cool tools within that same suite that are very useful, such as the ability to map a power path. We can grab a UPS and map the power path all the way down to every branch circuit that's downstream of it, or we can reverse that. Same tool set, very useful, but just laying out a 3D floor plan, not terribly useful for us. Doesn't mean it's not useful for other people, but for us it has a very low return.
Right. And I just, before I throw it open to the audience, I just want to ask, how do you get buy-in for people to actually use the tool? Because it is just a tool. If people don't enter the data, or they, it's garbage in, garbage out, how did you get people to buy into this?
Begging, pleading, lots of beer. What we've focused on is trying to roll out the features that are going to make their lives better first. So, as an example, my operators, every day, twice a day, they walk around the building with a clipboard and they write down all the relevant numbers that they care about off of every UPS and every battery string and every air handler. And it is a mind-numbing task. And when you show them that I have all of those pieces of data already in the system, and I can give them a report that is the equivalent of what they just did, and now they can spend their time walking around listening to the equipment, smelling the equipment, making sure visually everything looks good, but they don't have to spend hours writing down these numbers and then dictating them into the system and into a spreadsheet and keeping those spreadsheets for long periods of time. It makes their lives better. Suddenly they are very interested in using the tool and make it more effective.
Okay, any questions from the audience? Okay, I have more.
There's one back there.
Oh, there is?
Yeah, I'm assuming as a colo operator you used an electrical side model and you didn't mess with trying to get into your customers' servers to get that data. But when you did that, did you have to switch out all your CDUs from just regular CDUs to smart CDUs? And if so, how did you go about doing that?
Sure. Yeah. So as a colo operator, my responsibility ends at the branch circuit, at the cage wall, at the network port. We already had branch circuit monitoring because that's how we bill. That's our revenue stream. So I already had all of that data through a system. We pull it into an Oracle database. That's what we bill off of. And so I didn't have to switch anything out. I already had more points of data than I needed.
You mentioned that the data center changes from a day-to-day basis. How do you incorporate those updates? Are there many users that have updates? How does that managed and controlled?
Yeah, so we already had a workflow around that. When we talk about our system, part of it now is a piece of software we purchased, but a lot of it also is custom developed code and workflow we've developed over 15 years. So every time we install a rack, or a branch circuit, or a network port, that has to already be entered into our proprietary and matrix system because that tells our operators where the things are, that tells our financial system how to bill for it, et cetera. So I already had all of that data Now what we're doing is just mapping that data to the tool, so that as data gets changed in one source of truth, it flows over to the other tool. But we don't have a good workflow for the 3D visualization. So even though we install a new rack, my financial system now knows about it, my operation system now knows about it, somebody has to go in and land that rack in the 3D tool if I want it to show up there.
Hi, you mentioned transparency with your customers. What outputs of the DCIM tool do you actually provide to your customers?
Yeah, so let me start by saying it's a work in progress if any of my customers are in the room here. And so I can tell you about what we do and where we're going. So we already provide our customers branch circuit data. They can go in and look at their current results. We provide them network bandwidth if they get network services from us. We provide them visibility into our security system. What we will provide them out of this system is largely dependent on the size of the customer. So small retail customers, single cabinet customers, they're going to get historical trending of the branch circuit. They're not going to get things that are upstream, because if you're a single cabinet customer, you don't really care. My larger customers, my wholesale customers, where they've got multiple megawatts with me, we're giving them the entire power chain. So they can see the loading on the branch circuit, they can see the RDUs, they can see the UPSs, they can see the state of the generators. We're going to be giving them dashboards that show them the PUE of the building, et cetera. Our goal is to be as transparent with our customer as possible. And again, we're still working with our vendor to figure out the best way to give some of this data to our customers securely, by which I mean, if I have two customers, customer A should see their data, customer B should see their data, but they shouldn't see each other. But there's some data that crosses over. Like if I give you a temperature map of the room you're in, you're going to see the temperature of your neighbor. And that's okay as long as you don't know who your neighbor is. So we're working our way through some of those processes. But the default position is give them as much as we can. I think we have time for one last question, and then I know everyone's really here for the watch, so we're going to do a raffle. Go ahead.
All right, then I'll make it quick. Hi, it's Karsten Baumann with Schneider Electric. So Bill, thank you so much for helping us to understand, what you were going through this. One of the things you mentioned that you twice the resources, twice the money, twice the time, and I can imagine as the CTO, you had to also not only bag him with drinks and beers and whatever, but you had to ask for the money, right? So what's the economic benefit for having the system, specifically knowing now that it took twice as long or cost twice as much money?
Yeah, I'd say at best we're break even on our ROI right now. At worst, we're still negative. For us as a colo, there's a couple of economic benefits. One is through efficiency, and we're expecting to see a lot of efficiency gains in terms of the manual data. Also, shining a light into some of those dark corners actually drives efficiency, such as we had a situation where an operator turned off our airside economizing to do some maintenance, didn't turn it back on. Management didn't have visibility into that. Now they do. And so they can ask the question, why is this off? Turning it back on allows us to drive down the PUE. It's also a differentiator for us in the marketplace compared to our competitors. And so we believe it drives incremental customers, incremental customer revenue based on having these systems and a willingness and a philosophy of transparency that says, if I give you an SLA around ASHRAE TC99 for temperature, you don't have to trust me. I'll give you the data. I can prove it. So those are really the economic benefits for us.
So just briefly, I know we're running short of time, but what advice succinctly would you give to anybody out in the audience considering or through an RFP process at the moment with DCIM?
Understand what you're trying to accomplish. Choose the tool that you think will best let you accomplish it. Go small. Don't try to take on every silo at once. Take on one at a time. Don't be afraid to stop if you get into a rat hole and you don't see a way out. These systems are hard, and they're good, but they are not for everyone. And so understand what you're trying to accomplish, measure as you go, and lastly, make sure you have good cross-departmental engagement. This can't be an IT-driven project. This can't be a operations-driven project. It's got to be holistic, or it will not succeed.
Thank you. Okay, so I think everyone's waiting to see who's going to be the owner of a new Apple Watch.
Did we get cards? Okay, here they come. Any last cards? Get them in quick. Must be present to win. No purchase necessary. All right. Hurry, hurry, hurry. They're gonna hook us off the stage here in just a second. All right. So while we're waiting for that, thank you all for your time. I will be around throughout the rest of the day if anybody has updated questions, or also hit me on Twitter, and I'm happy to answer anything you want to know and go deeper into any of these topics. There's a lot of interest in the watch. Oh, sure. So apparently we actually have 2 Apple Watches. We're going to do one raffle now and a second watch at our booth. So if you didn't get your card in here, you have a second chance to win. I'm going to mix these up and then...
I do not have a card in here, sadly.
I have 30 cards in here, but okay, here you go.
Okay.
The winner is?
Our lucky winner is Scott Jones at Jacobs. Scott?
Congratulations. Scott, are you here?
Congratulations.
There he is. Great.
Thanks very much, Bill.
Thank you.
Thanks very much, everybody.
Thank you all.